Hello everyone, I will present online for the poster of StoryGPT-V, large language models as consistent story visualizers. The existing challenge of story visualization is that the image generation models trained on single images lack the continuity to capture evolving narratives across multiple frames. Story visualization requires generating consistent characters and scenes from text while resolving pronouns like she, he, or they over time. Here is an example source from Make a Story. In text without references case, each caption should be self-contained, including the name of the character at the beginning of each sentence. This is quite different from natural languages. In real world, instead, a more natural story description should be as the second line, where Fred and Barney will be replaced with they in the follow-up sentence. So to solve this problem, we propose StoryGPT-V to generate a story with consistency in two-stage training. Character-aware LDM, we enhance the text representation by integrating the visual features of the corresponding characters, then refine a character-aware LDM for better character generation by directing cross-attention maps with character segmentation mask guidance. Then we need to train a multimodal large language model for consistent story visualization. We leverage the language model's reasoning capability for reference resolution and the synthesis of coherent characters and scenes. We adapt language model by interlacing text and image inputs, empowering it to implicitly deduce references from previous context and produce visual responses. Let's first look into the first stage training. We first extract the visual features of corresponding characters need to generate in the current frames. Then we fuse the multimodal characters embedding by integrating character visual features with the text embedding, serving as the char LDM's conditional input. Then we encourage the cross-attention map AK for each character K at the token index position ICK to align with the binary segmentation mask MK, whereas diverging from irrelevant regions. In the second stage, we enable multimodal large language model for story visualization. In this case, we need to add R visual tokens to the vocabulary of language model for visual generation. We have visual token generation loss, the same as the next token prediction for text generation. And then we have the alignment loss to align the output's visual tokens to the input space of our first stage generative model character LDM. And the third, we also add denoise loss to force the pixel level consistency. So for the generation of the current frame, the model takes the multimodal context, which are the previous captions and frames, as well as the caption for the current frame as input. The generated visual token then map to the character LDM to generate the current frame 4. Here is the main experimental results comparing with the SOTA story visualization model on Flintstone in the referential text setting. Our approach improves the character accuracy and the background consistency by a large margin. We also use fine-tuned blip tool as an evaluator to assess the semantic alignment between the generated frames and the corresponding captions. Also shown in blue and cedar scores that our model have generated stories with higher semantic alignment. And here's the table for ablation studies on embedding fusion, multimodal context input, and denoise loss. We found that fused model embedding is better than only use the text embedding of the character names. And the interleaved multimodal context, which means it contains the previous frames and captions, is better than only use the captions as the context input. And the pixel level supervision further improves the character and the background consistency. Here is the qualitative result showing that compared with LDM or story LDM, our approach is able to generate accurate character given ambiguous references in the story description and better background consistency. We also visualize the attention map of the generative model. The attention map of our character LDM pay better attention to the corresponding characters compared with the baseline LDM. Our model leveraged the strong reasoning ability of large language model, effectively addressed the ambiguous references problem in story visualization. Our model can generate longer stories with accurate characters. Compared with story LDM, which need to maintain a large attention memory to keep the generation consistency, our model only uses 8 tokens to represent each frame, achieving faster speed with lower computational consumption.